Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering a whole new topic called information disclosure. In this video, we'll go over all the fundamental knowledge that is required to understand information disclosure vulnerabilities and complete the 5 hands-on lab exercises that we'll be covering in the upcoming videos. Alright, let's get started. The agenda for today is to first cover the technical details behind information disclosure vulnerabilities. So, what is an information disclosure vulnerability? What are the different types of information disclosure vulnerabilities? How common are information disclosure vulnerabilities? And so on. Next, we'll cover how to find information disclosure vulnerabilities from both a white box and a black box perspective. So if you're given an application and possibly even the application source code, how would you approach testing the application to determine that it's vulnerable? Once you have found that the application is vulnerable, how do you exploit the vulnerability in order to achieve your end goal? And then we'll end the presentation by covering the different techniques that you can use to prevent or mitigate information disclosure vulnerabilities. Alright, let's get started with the first section, which is what is information disclosure, and then what is an information disclosure vulnerability. Information disclosure, or also known as information leakage, is when a website unintentionally reveals sensitive information to its users. This information could be in the form of data about other users. So, for example, usernames, or even worse, personally identifiable information, or PII. It could be sensitive commercial or business data. It could even be technical details about the website and its infrastructure, so technical data. Now, information disclosure vulnerabilities can arise in countless different ways, and so it's difficult to go over each and every example of this type of vulnerability. And so what we'll do is go over the most common ones, starting with having stack trace enabled. Having improper error and exception handling with stack trace enabled in the production environment is the perfect recipe for attackers to generate error messages that expose the frameworks and libraries that the application is using in the backend. In the example you could see on the screen, this error was generated because a malformed string was entered in an input parameter field. It outputted the stack trace, which is a verbose error message, informing us that the application is using the faster XML Jackson databind library, which previous versions of this library have been known to be vulnerable to deserialization vulnerabilities. And those vulnerabilities led to remote code execution. So for me as an attacker, now I know that I should for sure test for that exact vulnerability since the application may be using a version of faster XML that is vulnerable. So essentially, having the stack trace enabled allowed me to enumerate the backend technologies that the application is using and then customize my attack to fit those specific technologies. Another really simple example of an information disclosure vulnerability is verbose headers. In this example over here that you could see on this screen, the verbose headers in the response of the request leak information about the backend technologies that the application is using. So you could see over here, the web server that the application is using is Microsoft IIS version 10.0, and the framework that they're using is ASP.NET version 4.0.30319. Again, knowing all this information could help us further customize our attack. Now, like I said, information disclosure vulnerabilities could arise in countless different ways and for countless different reasons. But a large portion of information disclosure vulnerabilities are due to cryptographic failures. A really simple example of a cryptographic failure that leads to information disclosure is the use of an unencrypted channel to transmit information. So, using HTTP instead of HTTPS. With HTTP, it's an unencrypted channel, and so anyone that is sitting on the same network can intercept your traffic and view it in clear text. Over here, I logged into an application that was running over HTTP and then intercepted the traffic using Wireshark. as you can see, my email address over here, which was the username to the application, is completely in clear text, and same goes for my password, which was admin123. Whereas when the application was using HTTPS, it's completely encrypted. And so although I performed the same login over here, when I intercepted the traffic, you can see it's complete gibberish because all that information is encrypted. Another common example of a cryptographic failure that leads to an information disclosure is storing users' credentials in clear text. Now, when credentials are stored in clear text, not only are they available to anyone who has access to the database, like the administrators or the software developers, but it also introduces the risk of attackers obtaining access to these clear text credentials if a data breach ever occurs in your application. And trust me, data breaches occur all the time. You should always assume that there will be a data breach during the lifetime of your application. And what happens if there's a data breach? The first thing that attackers are going to do is harvest the credentials and then log into the application and try to steal sensitive information from your own account or perform actions on behalf of you. Now, had those credentials been hashed, the attacker would have a difficult time recovering the clear text passwords for those credentials. And this brings us to our next example, which is the use of a one-way function without a salt. Now, in this example over here, the developers are a bit more security conscious, and so they have hashed all of their passwords using the SHA-256 algorithm. For those of you that are not familiar with hashing, hashing is essentially just transforming a string of characters to a fixed size value. So for the example over here, let's say the password is password1 exclamation mark. That would be the string that is transformed to a 256-bit fixed value using the SHA-256 algorithm. Now, the nice thing about hashing is that it's a one-way function, which means that if an attacker obtains a hash, it is computationally infeasible for that attacker to reverse this hash and obtain the clear text password of that hash. And that's why hashing is the perfect solution to storing passwords. Now, there's still a cryptographic flaw on this slide in the way this hashing implementation was done. Although I can't reverse this hash to the clear text password, what I'm going to do as an attacker is take a dump of the most used passwords in 2022, and that's something that you could find online easily. And then I'm going to hash them using the SHA-256 algorithm and save them in a table. This table is called a pre-computed hashes table or a rainbow table. Now, when a breach occurs, all I have to do is check if any of the hashes that have been dumped in the breach equal any of the hashes in my pre-computed table. If there's a match, then what I have to do is look at the corresponding plain text value in my table and then use that to log into the application. Now, if the hashes were salted, this attack would not work, because when you salt a hash, you add a different random string as input to your hashing function for each individual entry or password, and so I no longer can pre-compute my hashes table because I don't know the salt upfront, so that's one thing. And the second thing is when I do find out what the salt is, I would have to create a rainbow table for each individual password entry versus having one for all password entries. So adding a salt significantly increases the time required for me to conduct this attack. Alright, like I said, there's a ton of examples of information disclosure vulnerabilities. I have a few of them on the screen. Like I said, they're countless, and so it's impossible to go over all information disclosure vulnerabilities, but these are just some of the common ones. So obscuring passwords or sensitive information using trivial encoding algorithms. Encoding by default means that it's reversible, and so an attacker could just reverse the encoding mechanism and view the password or sensitive information. The second one is transmitting sensitive information in clear text over a communication channel that can be sniffed by unauthorized actors. We've already saw an example of that. That's where you use HTTP instead of HTTPS. Third one is hard coding credentials such as passwords or cryptographic keys in the application code. You should always have a secret manager or a secret management solution where you could store credentials instead of having to store them in your application code. Another example is using insecure hashing or cryptographic algorithms. So we saw implementation flaws in hashing functions not using a salt, but you could also use a hashing function that is known to be insecure and therefore has been deprecated, like MD5. Those hashing functions are known to have collisions and so should no longer be used in order to store passwords. You should use a cryptographically secure algorithm to store passwords. Improper verification of cryptographic signatures. So not properly verifying the signature, let's say for example for JSON web tokens, allowing an attacker to essentially bypass authentication. And then verbose error message or business design. This is essentially the way the application is designed just leads to information disclosure. So a really simple example of that is having a login page. If you put in a wrong username, it'll say the username is incorrect. If you put in a correct username but an incorrect password, it'll say the password is incorrect. In this case over here, the verbose error message allows an attacker to enumerate the valid list of usernames in the application. And so it's important that when you're designing the application and you're outputting error messages, the error messages should be generic and do not leak information about the backend system. All right, in the past couple of slides, we discussed the technical details behind information disclosure vulnerabilities, and we saw a few examples. Now let's talk about the impact of such vulnerabilities. When discussing impact, I like to refer to the SIA triad, so how it affects confidentiality, integrity, and availability. Usually, information disclosure vulnerabilities only affect confidentiality because, by definition, they leak sensitive information about the system. Now, in rare cases, they can affect integrity and availability in the sense that if you are able to leak, let's say, an API key or a session key, then you can perform actions on behalf of another user, such as altering content, so affecting integrity, or deleting content, so affecting availability. In the same sense, if you compromise an API key or a session key of a highly privileged user, like an administrator user, and again, let's say that user has the ability to upgrade the application from the UI by uploading the upgrade file, and let's say the upgrade functionality is vulnerable, then you could use the information disclosure vulnerability to compromise the administrator's account, and then the file upload vulnerability to gain remote code execution on the system. So it is possible to get an RCE using an information disclosure vulnerability, but usually it requires you to combine another vulnerability with the information disclosure vulnerability. Okay, so we talked about the impact of information disclosure vulnerabilities. Now the question is, how common and how critical are these types of vulnerabilities? One way to measure that, and it's not bulletproof, is the OWASP Top 10 list. For those of you that have not heard of the OWASP Top 10 project, it's essentially the list of top 10 most critical security risks facing web applications today. It's updated every couple of years, so you could see over here we've got the 2013 list, the 2017 list, and the most recent one as of this recording is the 2021 list. If you look for information disclosure or sensitive data exposure, you could see over here in 2013, it was the sixth most critical security risk facing web applications today. And then it was moved up in 2017 to the third most critical security risk facing web applications today. And it might seem like it disappeared in the 2021 list, but it actually got moved under the second most critical security risk facing web applications today, which is cryptographic failures. If you look at the OWASP website, you could see that it got shifted to position number 2 and it got renamed because sensitive data exposure is more of a symptom rather than a root cause. And so they decided to focus on failures related to cryptography, which usually lead to sensitive data exposure, and decided to rename it and put it under that category. Now, there is a huge debate about that, but we're going to go with the official guide, which is it falls as the second most critical security risk facing web applications today. And so it should definitely be checked for and it should definitely be addressed when you're testing applications. Alright, in the past couple of slides, we discussed what information disclosure vulnerabilities are. We saw a few examples, and then we talked about the impact of these types of vulnerabilities and how common and critical they can be. In this section, we'll discuss how to find information disclosure vulnerabilities. So imagine you've been given an application and asked to test it. How would you go about testing this application to see if it's vulnerable? I've decided to split this section into two categories depending on the perspective of testing, and the two categories are black box testing and white box testing. For those of you that have never heard of these terms before, black box web application pen testing is when the tester is given little to no information about the system. Usually, the only information that the tester has access to is the URL of the application and the scope of the engagement. Whereas for white box web application pen testing, it's the complete opposite. The tester would be given complete access to the system, including access to the source code of the application. Now, there is a third category that I haven't included on the slide, and it's called gray box web application pen testing. This is a combination of both white box and black box pen testing, where the tester is given limited information and access to the system. So for example, instead of just giving the tester a URL to the application, the tester is also given accounts to the application. When it comes to my methodology of finding information disclosure vulnerabilities, I loop both gray box and black box pen testing into one category, and that's because my methodology is essentially the same for both categories. If I'm approaching it from a black box perspective, my scope will just be a little bit more limited than a gray box perspective unless I find an authentication bypass vulnerability. But either way, the methodology is the same when it comes to looking for information disclosure vulnerabilities, whether I'm doing it from a public page or an authenticated page. And so I loop those two categories together. Whereas for white box pen testing, you're given access to the source code, and so the methodology differs and it has to have its own category. Alright, before we start off with talking about how to test applications from a black box perspective, it's worth mentioning that sensitive data could be leaked in all kinds of places. And so the first step is to really understand which data is sensitive and be able to recognize it when you come across it in an application. Personally, I always find information disclosure vulnerabilities in the penetration tests that I do, and when I report them, I would say at least 60% of the time the developers didn't know that that information should be considered as sensitive and that it could potentially help me as the attacker in further customizing my attack. And so it's really important that you're able to identify which information is sensitive and which information is not. The next thing that I usually do is just map the application. So visit all the different pages in the application and then go through all the workflows while intercepting and then reviewing all the requests and responses in an intercepting proxy like Burp. So a lot of the time you'll see that information is disclosed by design. So an example of that is the login page that gives an error message. We talked about that in one of the earlier slides. If you put in an incorrect username, the error will say that the username is incorrect. If you put in an incorrect password, the error will say that the password is incorrect. Now, this verbose error message allows you to enumerate the list of valid usernames in the application, and that's why it's considered an information disclosure vulnerability. Another simple example that I've seen in a real life banking application is an application that allows you to transfer money from one account to another. Now, when you do transfer money, you have to put in the account number. And when you put in the account number, the application makes an API call. And the response in that API call actually outputs all the account numbers in the application. Of course, you as a regular user don't see that since it's done using the API. So you won't see that in the browser. However, anyone with an intercepting proxy is able to make that request and therefore enumerate the list of all account numbers in the banking application. And so it's really important that you actually, one, understand and recognize sensitive data, and then two, see if the application just by default or by design leaks that sensitive information. Next, you fuzz the application and observe the responses of the application to see if it leaks the stack trace or debug info or even verbose error messages that leak information about the backend technologies that the application is using. And we saw an example of that in the past couple of slides. You could also brute force or enumerate directories in the application that are not directly referenced in the application. So, for example, backups or hidden functionality in the application. In several of my pen tests, I've found files and even directories that are not directly referenced in the client source code of the application. And so, if you're not looking for them, you won't find them. However, if you try to brute force or enumerate directories, you will find them, and those directories usually leak sensitive information about the application or its data. So I've added the three dots over here to indicate that there's many other ways to test for information disclosure vulnerabilities, and it's really difficult to enumerate all the ways, especially that information disclosure comes in many forms, and it's usually a result of exploiting other vulnerabilities like an access control vulnerability or a path traversal vulnerability or a SQL injection vulnerability or even a command injection vulnerability. And so there's really no specific way to test for this vulnerability, and your methodology is usually just developed by experience when you come across these types of vulnerabilities during pen tests. All right, moving on to the white box perspective where you're given access to the source code of the application. The first thing that I do is review the server and application configuration for any debugging or diagnostic features that are enabled in the production environment. If you have access to the code, you could just check the config files to see if the application outputs generic error messages and if the application has stack trace enabled. Of course, it's completely okay to have stack trace enabled in a non-production environment that is not externally available to end users because it's used for debugging purposes. However, in a production environment, you need to definitely disable stack trace because as you saw, we saw an example where stack trace allowed us to enumerate the third-party libraries that the application is using, and one of them was vulnerable to a remote code execution vulnerability. This allowed me as an attacker to further customize my attack and know what to test for when it comes to trying to exploit and gain access to the application. The next thing you could do is review all error messages to determine if they leak sensitive information. So from the black box perspective, we were stuck giving the application different input values to see if we could get error messages that potentially leak sensitive information about the application. However, if you have access to the source code, you could just review all the error messages to see if they leak any sensitive information. The third one is intentionally broad, so audit code to identify potential information disclosure in the code. So like I said, information disclosure could happen in many places in the application and for many reasons. And so it's difficult to exactly describe how to audit the code to identify potential information disclosure. So instead, what you could do is identify what information is considered to be the very sensitive information in your application, and then audit the code for the sensitive functionalities in your application that could potentially leak that sensitive information. And then the last one is if the application integrates with any third-party technologies, review the configuration for insecure or relaxed security features. So this is a pretty important one. Usually when I see that the application is using third-party technologies, the first thing that I do is go to the documentation that is available online for this third-party technology. In that documentation, almost always there's a security section that describes all the different security features and whether they're enabled by default or disabled, or if you're running into issues, you could disable this specific feature and so on. And what that does for me as an attacker is it actually helps me figure out if one, the default configuration is insecure or relaxed, and two, if the user has the ability to disable that security feature in order for their application to quote unquote work better. And so I would just test for these features to see if they do have any configuration that is insecure or relaxed that could potentially allow me to exploit the application. And that's it from a white box perspective. Okay, so far we've learned the theory behind information disclosure vulnerabilities and how to find these types of vulnerabilities from both a white box and a black box perspective. The next thing we're going to discuss in this section is how to exploit information disclosure vulnerabilities. This one is again a very tough question to answer because, like I said, sensitive information can be leaked anywhere and for any possible reason, whether it's a design flaw or a configuration flaw or any of the 1,000 other reasons that could potentially leak sensitive information. And so instead of attempting to go through all the possible scenarios, in the upcoming videos, we have 5 hands-on labs where we'll go through different types of information disclosure vulnerabilities and how to exploit those vulnerabilities. Of course, when it comes to exploitation, I do have to mention web application vulnerability scanners. These are automated tools that crawl your web application and look for vulnerabilities. Now, any decent scanner should have the ability to report on information disclosure vulnerabilities like stack trace being enabled or the application using verbose headers. Most scanners also have regex strings that match on potential sensitive information like email addresses or phone numbers and IP addresses and so on. So running a scan should definitely be something that you should add to your methodology if you haven't done so already. I personally use the Burp Pro scanner, but there's so many other options that you could choose from, ranging from options that are open source to ones that are free and then to ones that are very expensive. So it really depends on what you're looking for and which scanner you're comfortable using. All right, moving on to the last section, which is how to prevent information disclosure vulnerabilities. The first thing that you need to do is ensure that all the teams involved in producing the application are aware of what information is considered sensitive. Like I said, 60% of the time when I find an information disclosure vulnerability and I report it, the developers usually have no idea that this information is considered sensitive, and they had no idea that I could use this information to further customize my attack. And so it's really important to ensure that everyone that is involved in producing the application is aware of what information is considered sensitive and what information is not considered sensitive. And what that'll do is it'll ensure that the developers don't make any unintentional mistakes of leaking that sensitive information just because they didn't know that it was sensitive. The next thing to do is audit the code for potential information disclosure as part of the QA or build processes. So whenever new code is introduced into the application, it should be checked by another set of eyes to ensure that the added code doesn't leak any sensitive information about the application or its data. Wherever possible, use generic error messages. We talked a lot about this one. So error messages could potentially leak sensitive information about the backend technologies that the application is using or the data that is in the application. And so it's absolutely important that whenever possible, you use generic error messages that don't leak any sensitive information about the application. Number 4 is double check that any debugging or diagnostic features are disabled in the production environment. So having stack trace in the QA environment or non-prod environment is fine. However, when it comes to the production environment, any debugging or diagnostic features should definitely be disabled. And then last but not least, review all configuration settings for any third-party technology that you implement and make sure to disable any features and settings that you don't actually need. Like I said, when I see the application is using any third-party technology, the first thing that I do is go to the security documentation for that specific technology that is available online, and I see if there's any settings that I could potentially exploit. And so, as a software architect or as a software developer, what you should do is properly review all that configuration. Anything that is insecure by default should be disabled, and just in general, any features that you don't use should be disabled because the more features you have, the broader your surface for attack is. So anything that you're not using should be disabled, and any security features that are available for you for that third-party technology should be enabled. And that is it for this section. We've reached the end of the video. I have a few resources available on the slide if you're interested in learning more about this topic. So the first one over here is what the presentation is based on. So the Pertswigger Academy and then the corresponding chapter in the Web Applications Hackers Handbook. I also have a few OWASP resources and a really good article by Troy Hunt on how response headers could potentially leak sensitive information about your application. In the next few videos, we'll gain some hands-on experience exploiting information disclosure vulnerabilities.